Hello, everyone. Thank you for joining today. Today we'll be talking about introducing the state pattern. So you have actually been working with state machines in the past. I, any animations you've done have typically been using a state machine and things like that. So in Unity as well as Unreal, you guys had a little bit of hands-on experience with having a state associated with transitions. So what we'll be doing today is just talking about the different assignments and then taking a look at an application that we could make using the state machines and things like that. You will still have to watch the lecture here that's pre-recorded, as well as the go through the experiment, which will set up a light just turning on and off based on a click to set its state on and things like that. But we'll be making our own kind of separate additional one outside of the normal material today. The test right here will be based on the recorded lecture from that session. Seeing dynamic actions with states was super cool in Unreal. Okay, cool. Glad you enjoyed that. And this test also goes into a little bit about the state machines here, which will probably cover almost everything that this one will, but it's always good to go through that and see it done another way and explained in a different manner. All right. So as I mentioned, you have worked with them before, so we're going to just jump into an empty project I have right here and take a look at how we could create a state machine for not just animations, but actually our code itself. So rather than running all our code at once inside an update, we can just run whatever it needs to check at the current time. So for example, let's see, what kind of state machine? We could do one for like a door, having a door open. Would you guys be okay with that? Then we could add some special states to it. Yeah, let's do a door. All right. I know you guys have done plenty of doors in the past, but let's do one real quick here. I'm gonna just add a quick floor for the grid, floor for the ground, and zero that out. And then let's build a quick door. Let's just do a cube to start off with. Make it a bit thinner. And let's also put this door along, let's say like we have walls and stuff around it, so we can't really get through until we open the door. Yeah, let's just duplicate this real quick. And we'll view it from the other side like our game view is set up. I'm gonna add a quick material here for that. I always forget where that material is. And we'll make our door, let's go for like a brownish color. A little bit more of a burnt orange, but that's all right. So we've got this pretty simple door here. I am gonna make sure to name it door. And we'll name the other stuff wall. And just make sure that it is closed up there. So for our door, let's go ahead and put a script on it. We'll start off very simple with just having two states for whether it's open or closed. And then we'll look at some other options for it. Let's add a script for it. to control it. We'll call it our door state machine. Open that up. There's a few things I want to do with this door. I want to define a couple of things. We'll just be moving it in code rather than having an animation player or anything like that. So our first thing we'll do is add, well, we don't even need to add any vectors. We can just hard code it for now to keep it simple. So we'll start it off with when we press space, we'll have it open. So if we press space, input dot get key down. Darn you, IntelliSense, for being so good and getting me used to using it. Key code, space. When we press space, we'll lift the door up. I'm going to just simply take our transform and change its position. We'll be adding a vector to it. New vector. Ah. 0 in the X, but we'll push it up, let's say 5 units. I think that's about how tall I made it. If not, we can always adjust that. So when I press space, just simply moves this object up. All right.
Wouldn't it be smoother if you delta timed it?
It would. I'm just looking for a single press, like get key. If I was doing get key and I was like holding spacebar, I could do like a multiply by time, but this is just a single press. I just want it to move up 5.
All right, so it's just gonna like teleport up basically.
Pretty much, yeah. It'll be one single frame, move 5 full units.
Yeah, the reason I ask is because I recently was doing a platformer personal project, and I had to learn about delta time movement based on raycast.
Okay.
Yeah, which was pretty neat.
Yeah.
Instead of using animations, because I used animation for sprite animation, but I used delta time for movement.
All right. So we'll start off simple, and then we can look into lerping and using delta time to make it smooth and everything. But if I click in the game, and I would help if I attached the dang script. So right now, it does not have a script, and I'm not in a navigation project, just going to close out of that tab. If you didn't know, all these tabs work just like tabs in browsers. You can center click to close any of them. But we will attach our door state machine script here, even though it's not a state machine yet. It's just a real simple script that if I press space, it shoots up 5 units. Well, look at that. That is a lot higher than I was expecting. Maybe 1.5 units. Ooh, that's looking nice. So 1.5 is what we'll change that to. And just to see what it started off at, it looks like it is even starting at 0.2, maybe 0.5. So it's probably starting at 0.5. We'll bump it up to, so we're just adding 1. All right, so we've got a full delta of 1. Let me just add that person real quick. There we go. So 5 units, way too big. 1's much better. Play this, press space, we got the door open. If we press space again, obviously we aren't taking into account if it was already opened. So that's our first thing that we'll need to do. And we can do this with just a standard script. We could add a bool here and say is open. And we'll start it off as false. And then when we press space, if it is open, we would want to close it. Else, we'll just do the normal open. But when it is open and we want to close it, we'll just push it back down one. -1. All right, so we should be able to open and close now. Open. Oh, did I not save? Oh, I never set the bool.
You never set the, yeah. You never actually made the transition state. You just made the transition state exist.
Yeah. Let's make sure that if it is open and we do tell it to close, it will now be not open. Is open is false. And is open would be true if it wasn't open and we just told it to move to the open position. All right. So now when we press play, press space, it opens, press space again, it closes, and we can continue that as much as we want. Before we get into converting it to a state machine, I did like your idea, just making it smoother. So what we'll do is, if it was open, let's change this a bit. So the space bar will just tell it to start opening or transition to the open. If we press space, we'll paste that code back down here. We will tell it to open, or is open equals the opposite, not is open. So I no longer need to do this stuff. I'll let that transition like normal and only change it based on this. And when it is detecting that it should be open right now, we can do a couple of things and have it actually lerp to the new position and things like that. Let's add another bool for currently transitioning. Or let's do a float so we have a specific time. And what did I didn't spell that wrong. I just saw the red squiggly and was like, what? Let's do 5 seconds is a long time. Let's just do a 2-second door. Still a pretty long time. All right. So
Couldn't we have just used an animation?
we could have, yes, but I will be adding some other states to this other than just open and close. So let's say like a partial open, a locked state, and things like that. And once we actually convert it so it's not running all the code and update, you'll see why we would want to use a state machine for it. So is open changes. If it is open and transitioning, if transitioning time is greater than 0, we will just be telling it to move down, and we will go by that delta time. And so that'll go for 2 seconds. So it will move a full unit or full 2 units. I'll just alter my speed right here. We'd have to do the same thing for the transitioning of when it's not open. If we do have any time, and we'll also count down our time. Transitioning delta minus equals time dot delta time. And down here we'll
You forgot to
do
close the
same
curly
thing.
bracket on the if transitioning is greater than 0.
I do see that, yep. But need to add it down here too. All right, and convert this 0.5 f times time dot delta time. So that'll be moving up. We gotta remember. Yes.
Professor, real question. Like, what's the primary, like, I still get delta time and just normal time mixed up. I believe delta time is counting like actual seconds, right? That's the one we use for actual, our real life seconds. While time is frames.
So time dot delta time is the amount of time since the last frame ran. So since we're doing this in update, we do need it to be time-based. So our update, if we want something to count down real life time, we can minus equals delta time here. Or want it to be scaled or translate based on that time dot delta time, we have to multiply that in. Because that's how often this function gets called. So basically, if you're running at 60 frames a second, this time dot delta time would be 1/60th of a second.
All right.
All right.
Yeah, I missed the, what's the transitioning variable? Is that int?
It's a float.
It's a float, that's what it is, okay.
Yep. So float, and I just defaulted it to a value of 2. All right.
All right.
So we're going to save this. And we'll take a look at this run now. We should have smooth door. Oh, and it went to, because I defaulted our time to 2, it told it to move. We are going to default that to 0 and just set that whenever we need it to move. So for example, in our space, it wouldn't have moved. I need to make sure to reset our transitioning to a value. Because all of this code is all running at the same time. Every update, every frame, it's going to be checking, is it open? Otherwise, let's check if it's transitioning and stuff here. Now, all right, now it'll wait till I press space, and we've got it closing. So I have something backwards. Well, it's a door that slides up from the ground now. Not quite the intention, but I definitely
You froze. You said otherwise. Let's check if it's, and it froze.
Okay, sorry about that. So right now it's going backwards, and basically I have something out of whack here. I think I did, if it is opening and transitioning, we are doing upwards. Oh, okay. Yeah, so I kind of reversed this. If I want to say if it's not open, but it is transitioning, so it's trying to transition closed, it would be going down. Okay. Should be good to go here. And we should have it opening up again. Press space, and it is going up. Press space again. We've got it closing back down. Let's say we wanted like a third state where a character would walk up, but the door's supposed to be locked or like a bit broken. And we had a partially open state. Well, I'd have to add another bool or something like that to take that into account. And that can get pretty sloppy if I just have a bunch of ifs all over my update. And every frame, that's taking up extra cycles. Running code it doesn't really need to. The only code it really needs to run per frame is checking if we pressed input to transition to another state and doing the actual transitioning. So let's change this up and create a some sort of holder so we can have just one function run at a time when it's in a specific state. We're going to create an enum, or the longer name for that is enumeration. An enum is a way of basically associating numbers with readable words in text. So it's great for things like states, stats, things like that. We'll do an enum. We have to give it a name. We'll call it door states. And then we can give a couple of names for the states. We'll have open, closed, and we'll add on partial. We won't do the partial state yet. We'll just get it working with the open and closed and then add that in a moment. And typically with enums, as a good habit, you usually add an extra one at the end just to signify how many door states exist. Since these are just numbers, anything at the end will be basically the size or count of this state, of how many states you have, or enums. All right.
And Professor, with the enums, you like a method that it is it's capitalized instead of dia.
Yeah, it's just pretty common to have enums capitalized, and like if you do create an enum, initialize that with an E. Just common coding practices that I'm used to. And depending on what company you go for, or what your team likes, that'd be up to your discretion. So let's create a variable of that to hold our current state. We'll call it cur state. And we'll initialize it to closed eDoor states dot closed. And then let's separate the different parts of this out for, let's have one function run for each different state. Not if, what the heck was I thinking? We're going to be using a dictionary for this, and we're going to associate each one of the enums with what is called an action. An action might be a type that you might not have seen before. Action. And we do see that that comes from the system namespace. And we'll give this a name, states. And we'll initialize this to a new state machine. Oh, not new state machine, new dictionary. That's the wrong type. There we go. So we've got a current state. that we'll be using to access single action from the states. So we will need to actually populate the dictionary with associating which action would go with which function. So we're going to need to separate out those different states into their own functions. Let's go ahead and just add those here. State. Let's do a function. We'll just do a void function, no return. And we'll call this one state open. Don't need to take any parameters into this function. I'm going to duplicate this a couple of times. So we have one for each. State closed. And state partial. All right. So I'm going to get rid of well, I'll keep the transitioning bool. I do like that because that smooths it out, but or keep the transitioning float. But our bool for is open no longer matters. We will be using our enum to determine the state. We have our functions. They don't do anything yet, but we can at least add them into our dictionary now. So we'll say states.add, and we'll be adding our, let's do open state first. Open is going to be associated with state open. And so here's where we see that action delegate in use. The action delegate allows you to treat functions as a variable and actually pass that into other things and use it as a data type to basically reference a function. Then we'll go ahead and add our others. Closed will be for our closed state. And partial will be calling the partial function. Then our update, I'm gonna comment out all this stuff since that's just hard-coded and all the extra code. And our update now will just be doing whatever the current state is and calling that function. States sub whatever our current state is. And in order to call an invoke, in order to call an action, you can invoke it by using the invoke method right here. All right. So now we have whatever the current state is, just calling this function rather than doing a bunch of ifs determining which state it is, eating up cycles of doing branching, figuring out which one it needs to go to. It's just saying current state, go to that one. So in our state open, let's do closed first, I guess, since that's what it starts out as. When it is closed, we will ask if we do the input press, if input dot get key down, key code, dot space, we'd want to tell it to open. And for simplicity's sake, I won't use the smooth transition. I will rip that out just so it's a little bit easier. Transform dot position plus equals, and I could use a little bit of a cleaner method. Translate, and there is the XYZ right here. So 0 in the X, just 1 up in the Y, and 0 in the Z. We then want to tell it to switch our current state over to its open state. Under state open, we'll just be running this code here. We'll be
Aren't you
pushing
setting cur state in the variables? Aren't you setting it to open already? So shouldn't you change that to closed? No, your cur state is closed. Never mind.
I default it to close, and
Yeah,
then
never mind.
if
I
we
had it
are
backwards.
closed, we press space, we go to open. And then if we
Yeah,
are
my
open,
bad. For some reason, I remembered you putting it as open. My bad.
okay, no worries. And this one we'll be changing it to closed. All right.
Actually, I do have one thing. The state open, if input get key down, blah, 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 blah. Translate 1. Shouldn't that be translate -1 on the y-axis?
Yes, I think I was just about to do that, and then I didn't quite finish, so I just added the close,
I
but forgot the
distracted you.
negative one. No worries, it's all good. So now each state, it'll just run the single function it needs to and just check for what it needs to do inside each one of these. And our update, super simple. Let's test this out. We'll add the partial and maybe change some things up to get it smoother in a couple moments. We press play, press space, it opens, press space again, it closes. So in here, now if we ever have any problems with a specific state or what's going on, like why is it not transitioning, we have a much simpler thing to check versus having to check, all right, was this bool correct? Was this correct? Was it somewhere in this else? And as you keep adding more complications to the game, or like your player, for example, you can end up with 1,000-line updates, and that can be a pain in the ass to try and debug. Whereas if you do something, a specific action, like say try and get a transition working, each state itself is all self-contained and encapsulates just the code it needs to. It's easier for debugging. It's more efficient in the engine itself because only the current state is running code. It's not checking each state if it needs to run it and then just skipping it, things like that. So any questions about how it's currently set up? I know we still haven't filled out partial yet.
What are some other applications? Because like so far we've been talking about like animations, but what are some other applications that state machines can be used in?
State machines can be used in for just about anything with a state. Think about like your oven, even. Your oven, when you walk up to it, you need to turn it to preheat. That would be considered a preheating state. You have to wait for it to get up to temperature before you can actually open the door, start baking, or if it's on cleaning, the door could be locked, and that would be considered a separate state. For the cleaning state, your door is locked. Basically, any functionality that you would have change your actual what you do based off input would be considered a separate state. For example, if your character, if your player is just on the ground and you press space, it can transition to the jump state. But when it's in the jump state and you press space, if it's only a single jump game, then it would just get completely ignored. So there's no reason for that jump state to even have any input code checking for space or doing anything like that.
So it's pretty safe to say it just stops us from having to use so many if statements.
Yes, it basically allows only the code that needs to run to simplify the code down, make it easier for tracking down issues, along with making it easier to add new items and things like that. Like I mentioned when I was doing it initially, and we were just doing the 2 states, so we could use a bool, and then I wanted to add partial or partially open. We'd have to complicate our logic checks here quite a bit to figure out which state it's in.
So also simplifying then, like, because I see where you're going with that. If you kept that in that commented out section, you will be having to, like you say, having a whole bunch of states, or not states, but like just checks.
Yeah, anything I wanted to go to add to this, I would have to make sure all of these if statements or any of the logic here is checked correctly versus saying, well, let's say when it is closed, we could press space to go to open, or we could press a different key to go to a partial, or if our player has a key or not. Yeah, we could do that. Let's add that. Let's add a really quick player and make it pick up a key before it can open the door. All right. Let's see, we should be good on time. Yeah. So I'll add a capsule. Whoa, I made our door really tiny. Well, we'll make our player tiny too.
Yeah, I was about to say, let's Alice in Wonderland this.
All right. So more of just like a gate now instead of a door. Hopefully our player will be able to get through.
It's like, howdy, neighbor.
And I'm gonna do this part pretty quickly. I'm gonna just add a character controller component to
Weirdly,
it.
this makes me think of Goose Game.
Oh, yeah.
And add a new script, player script. I'm gonna get the controller reference. Yep. So somebody posted in comments, make sure you are using systems. That is actually required for our one right here. When we are doing the action comes from system. So when I typed it, it did make sure to have using system up top. All right, so in here, get the character controller, get component, our character controller. And then an update. We'll be doing a couple of things based off input. Vector 3 for move. And that'll be input, get axis, our vertical axis. Multiply, well, I won't do the multiplication yet. Or I do need something. I need to multiply it by our forward vector. And do the same thing for sideways, just not recreating, but adding on to our movement vector. And instead of checking vertical, we'll be doing horizontal. And that'll be on our right vector. And then tell our character component, our character controller to move simply. And we'll be passing in our move vector times some sort of speed. Let's do 3 units.
Professor, I know you're setting up a character controller. I just got curious, like, ooh, what if you use the nav mesh we learned the other day?
We'll we'll actually be doing that in a later lecture. For right now, I just need something moving around. So we've got that moving around. We're also going to add a bool for has key false, and we'll add some sort of pickup in here. Be a big old key that we can hit. Add a quick script for that, just for identification. Doesn't need anything in here. Think of that like just the nav point thing so that our player can detect when it hits it. On trigger enter. If other dot get get component is type key, not components, or pickup. And we'll set our has key to true. And I will make this has key public. So when we change some things up on our door, we can have it react to our player, check if it has the key, things like that. So our door, rather than doing update and checking for input press, we will be doing on trigger enter. We'll have to add a trigger to our door as well. And we will be checking if other is a player. We will try and go to whatever opposite state we have. So for example, here we would have to check if check our current state. If it is already open, then go to closed, etc. So kind of breaking that usefulness of the method, but well, we could do a switch, because you probably haven't seen that too often. Switches are super useful for enums. And we'll be switching off the current state case. Door states, if it is closed, we can specify code to run for that. Break out of the state. Add a case for the other door states. It is open. And we'll just do the 2 for right now. Fantastic. So decided to drop me out. All right. So all that I was doing was adding on trigger enter, switching based on what the current state is when we do hit the player. If it is closed, we will tell it to essentially open. But that's kind of anti-architecture, checking its current state. Rather than doing that, if we do detect a player, I'm going to just call a function. And let me actually screen share again. Yeah.
Yeah, that was just
Sorry about that. Forgot that gets kicked and dropped real quick. We will be adding a function here.
Did you get rid of the switch?
I did. I just deleted all that. That was right here before.
I was curious what that was going to do.
We can do that inside this function right here. We'll do void try open.
That player component comes from character controller, right?
Player is something I wrote. This is a script I added.
The script. All right, okay.
Yeah. Oh, and hasKey equals true. Now I see what that comment was about. Good catch. So we're going to try and open the door. We will be passing in the player here. I'll just call it P for inside the function. So if it does detect a player, we can call this function try open. And we'll pass in that player component. All right. So I've been adding a lot of stuff. Before I write this try open and add a trigger and things, I never actually tested my player. It's probably a good time to do that now. Let's see, our play. I'm going to select our player, which I didn't name. It's just capsule. Got to rename that. And we see it starts off with no key. If I click the game and try and move around using WASDA, nothing's happening. Oh, I spelled an axis wrong. Horizontal. Horizontal.
Question, is the character controller a default?
Yes, character controller is something built into Unity.
Oh, okay. Something I haven't used yet.
I know you guys haven't touched on it a bit. I like using it for just a really quick way to get character movement around a level. So
I tried using it with Cinemachine before, and things got wacky.
Yep, there's definitely some weird issues with certain physics and stuff. Oh, and I didn't mean to fall off the level. But for our purposes, works perfectly fine. We just needed something to get our character moving around our level, and it will have actual physics and react to things, and even slide like if we're doing forward and side. So very nice movement, and I don't need to use specific physics reactions for anything here, so no need for a rigid body. So our character just starts off no key. When we hit that, it does have a key. I should probably tell that pickup to destroy just as well. Make it a little bit cleaner. When we hit a pickup, we will also destroy the other game object, making it destroy the pickup. Oh, why did I do destroy twice? Other game object. All right. So we have a character. It can change its bool based on a gameplay interaction. Our state machine itself, we have it checking if a player enters a trigger. Let's go ahead and add a trigger volume on there now. Here's our door. It has one box collider. We'll add another box collider. I'll set this one to be a trigger and edit this out a little bit in front on both sides. Okay. So, on-trigger enter should be trying to open. We will ask if the player has key. Then we'll tell it to transition to the open state. For that, we were just saying this right here. We're pushing the door up and opening, or switching to our open. But we need to know more here. I want to know if the player, if it is already open, just ignore this. So if we're not currently open, current state is not equal to, rather than putting a not in front, that's for bools, to open. And it does have a key, and we tell it to transition to open. But let's say it doesn't have a key. We'll add a transition to open just part of the way, and then we'll have it go to a different state, and that'll be the partial. We'll do 0.2, should just be enough to see, to F. All right. So our partial state should be set up. Let's test this out, and we'll see what happens. If I walk into it with nothing, it does the partial open. Oh, and it's going to keep doing the partial open. So I'll eventually get it there. Oh, and it's not. My character's too tall. Darn you, player.
Is the trigger attached to the door?
Yes, the trigger is right on the door. I added just another component.
So when it moves, so whenever the door moves, the trigger goes up with the 2, right?
Yep. Yep, and I'm fine with that. I don't mind that too much. I'd probably change the layout of a couple of things here, but I was just doing it pretty quick for the gameplay example. Yeah, I'd have like a door container, and then inside there like a door panel and a door frame, things like that. But we'll keep it simple for now. Doing that door is perfectly fine. Oh, and I need to change the height of my character. That's what I was going to do. I keep forgetting to rename this player. And we'll drop him down 2.25. Short little fella.
Mm-hmm.
And he's going to get that huge key over there.
Looks like a candy. I can't remember the name of it.
Yeah, almost like a Smartie or something. All right, so we've got a key now. If we do go into that door trigger, we can walk through the door. All righty. So that was just a...
Wait a minute. If you open the door with the key and then press space, wouldn't it close?
Yes. So right now, our states themselves are kind of just using like a hacked transition, I would say. For example, if I press space, if I try and open, it's not opening because it's not
it's
in the
partial.
closed state. It's partial right now. But if we just start with it closed, I can open it and I can close it. And if I get the key and I run into it, let's say it was closed, I run into it, it is open now. I press space, it closes it back down. Could have a scenario like this where if I press space while I'm inside, it's going to drop onto my character until it's a reopen.
Playing explosion effect.
Yeah, just player smash, make it even shorter here. All right. But the general portion of the actual state machine, I wanted to show a little bit of logic of how you can actually change those states or transition to those states outside of just the state itself. So the states. Oh, sorry, go ahead.
Just a little bit further down, if in the transit, is it the try open? If and right there, instead of doing if current state is not equal to states not open, could you do if P has key and E door states or E state's current state is equal to open?
So I could have done that inside this if with an and here, but I would also have to come up with something else for this else statement. I just want to see like if it wasn't open already, ideally it would have probably been fine. So you're just saying just move that into here.
Two ends, right?
Yes. I'm just cleaning up the other code and then adding the second one now.
I got stuck for like 30 minutes on the code one time, and that's all I forgot was the and.
Oh, no.
Yeah.
The
Nice.
logical operators, 2 ampersands. All right. So that'll pretty much have the same behavior. My other one was just checking that in general. Now, if it's even, well, it won't ever react for if it is already open and we couldn't actually do the partial. Oh, actually, we can't because our collision volume doesn't hit it. But if our collision volume didn't move and we didn't pick up, or we did pick up the key and then walked up to it, it would not, it would run this one. Dang. Just thinking of a scenario where it might run this else incorrectly. There probably is one, but not going to worry about that. This was just a quick example, mostly highlighting the fact that you can have just one state actually run its update code. And if we did change this up rather than having our input check for anything, we could simplify this down and just say transformed position equals, let's have a vector for open, vector for closed, vector 3 for open, vector 3 for partial, and a vector 3 for closed. We'll make those serialized. Yeah. Oh, no, not Control X. I meant Control C. Damn it. There we go. We have 3 different vectors, and inside the states themselves, it'll just set its transformed position to that specific vector. This is open. For partial will be partial. Our closed will be closed. And now we no longer need to do any translate here, which simplifies this down quite a bit to make it a lot cleaner. All right. And transitioning, don't care about that. So each state will just set it to the position it needs, rather than doing all the input checks and everything. And I will just get rid of all the initial code that I wrote here, so we can see our entire state machine is quite simple now. Save that, and it should still work. Oh, no it won't, because I never set those positions on our door. Well, closed is what it starts out as. I'm gonna copy the value of position, and closed is that. Partial, we'll just paste our initial positions in there. Open was 1.5. Partial was 0.2. Oh, actually 0.7, because it's added to whatever its initial position is. Here we go. Now we get it to the partial. We get key, and we do get it fully open. And our state machine itself is now much simpler. All right. Any questions about the state machine in general? I know we pretty much wrapped up before I did the cleanup, but anything else while I got a couple minutes left? Nothing? Alrighty then. I hope you enjoyed today's session, and please be sure to check out the other lecture here, along with the go through that experiment to write your own for turning on a light and off, things like that. And then you can wrap up pretty much this week. Reminder about next week. Monday is a holiday. It is Memorial Day or Labor Day. I keep forgetting which one it is. So our next lesson or lecture will be held on Wednesday, and we will have one on Friday again next week as well. So I'll see you all on Wednesday.
Professor, if you have any questions, need to reach out to you. Is there a time that you're not available during the weekend, like Sunday, for example, or are you?
I'm generally not available on Sunday. I try and check in at least once throughout the day. So if you do have a question, make sure to shoot an email to me sometime in the morning on Sunday if needed. As well as Monday for the holiday, I will not be working. So try and get me a message to me before Sunday or wait for a response on Tuesday.
All right.
All right.
Well, thank you.
Sure thing. Alrighty, on. Later on, everyone.
Thanks.